properties of limits. Okay, I'm going to try and streamline here and just go through this, but this is how symbolically these rules are expressed. Really, it's going to be more about how we use them. So the constant rule, the limit as x approaches c of some constant k is just going to be equal to k. Because if we have the equation k, that is just a horizontal line. And so any place you're approaching on that graph is that value of k. So that's just saying the limit of some number is equal to that number when there's no variable involved. Okay. The limit as x approaches c of x, well, it's almost like you're just filling in c for x, and it's going to equal c. If you think about the line y equals x, the line y equals x is that perfect diagonal line.
What's the difference between 1 and 2?
Okay, hold on. The perfect diagonal line goes through 1, 1, 2, 2, 3, 3, 4, 4. Okay, so on 2, it's the limit as x approaches c of x. So you're plugging the value in. It ends up always being itself. I mean, I guess in looking, they're going to be the same.
It'd just be like a number on the first one.
Yeah, so it's like the limit as x approaches 4 of 8. Well, the limit of 8 is always going to be 8. As opposed to here, the limit as x approaches 4 of x, that's going to be 4 because you're plugging it in there. Okay? And I feel like, in all honesty, I threw a 4 in here out of habit. I feel like, in all honesty, this is one that you more often see like with an infinity or something there. But
okay, so limit of k, just to make sure the constant rule, the k is a real number.
yes, yes. Yep, k is a number.
And so c would be a variable.
Nope, c is a number also.
Oh, yeah.
Yeah.
The variable is the variable. Got it.
Yeah, actually.
We got lots of variables floating around here. Okay. Coefficient rule, and we'll demonstrate these. The limit as x approaches c of b times f of x. This is just saying if you have a coefficient, a number that you can essentially factor out or pull out, you can put that number out front and then just worry about the limit of the function. Again, I'll point it out. I'll show you some examples. Sum or difference rule. If you have two pieces added, you can break them up into separate limits. So the limit of x plus g can be doing the limit of f plus the limit of g. So I don't necessarily break them up physically, but I think about them as separate things. Product rule, same thing as the sum or difference rule. And the quotient rule, the same thing as the product rule. All of these, you can take them and break them into two separate limits and think about them as individual pieces. Okay, some of the information we're dealing with today really lends itself to these rules. The power rule, so this is just saying if you have a power on the function, you can take and just do the limit, because it might be easier to do the limit first, do the limit, and then raise it to the power, is what they're saying there. Now, the composite function rule. This is an important one because this is one where you don't split it up into two limits. Okay, so this is kind of a key one that we'll have to practice on. But the limit of fog, basically, right? The limit of f of g of x. Notice you can take the f out front and then do the limit of g. Once you get that limit of g, though, you're not doing another limit of f. You're just plugging it into f. And I know we have at least one example in the notes like that today. The root rule is very much like the power rule. It's just saying if you have a square root, you can just do the limit without that and do the square root at the end. Okay? So very quick. I think really by example is going to be better. I'm just trying to, make sure we have some keys. I guess the one thing I didn't talk about down at the bottom, it talks about, being skilled at reciting these in English will help you understand them better too. I mentioned them quickly, but the one that you hear a lot, the sum or difference rule can be stated as the limit of a sum or difference is the sum or difference of the limits. And so, like for this right here, they're saying this is the limit of the sum is equal to the sum of the limits. So it's saying that you can do the sum and then do the limit, or you can do each of the limits and then do the sum. Okay, that's how they're putting that into words there. So let's try to apply some of these. Okay. Hopefully I can squeeze everything in. I had to kind of leave everything full size because we need this graph of f and g here. Okay, so do pay attention. We have graph of f up here. We have graph of g up here. Now, this first one, the limit as x approaches 3 of f of x plus g of x. With what we're looking at, technically that's kind of hard to do as is because you can't really add f and g and then do a limit. And so this is where we can break it up into two limits. That's what our rule says. We can make this the limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 from the right of g of x. That's how that can be rewritten to make it easier for us. And then you're finding those two limits. So take to the graph and find them. Limit as x approaches 3 from the right of f is going to be 6 plus g of x, the limit as x approaches 3 from the right is 8, and 6 plus 8 is 14. Are we okay with that? In my brain, it's very easy and basic.
Mm-hmm.
But I gotta make sure you guys are there with me. Now, B is very similar. Okay, we can use the sum or difference rule again and split it into two limits, but there's also coefficients there. Okay, I believe, did they use the word coefficient rule?
Mm-hmm.
Yeah. So what I can do is I can also take the coefficients out front. So I'm going to write this as 3 times the limit as x approaches 5 of f of x. So that's the first part. Minus, I can take the 2 out front on the second part, 2 times the limit as x approaches 5 of g of x. So that's using that sum and difference rule, but it's also using the coefficient rule, where you can take a constant out front. Okay? So 3 times something minus 2 times something. I say something just because I haven't found them yet.
3 times 2 minus 2 times 4.
I can agree with that. And that puts us at
6 minus 8. -2.
okay. So pretty easy stuff here. I mean, enjoy this while we can, right? C, the limit as x approaches -5 from the left of f of x minus g of x. Okay. So officially it can be broken into two limits, being subtracted. limit as x approaches -5 from the left of f of x minus the limit as x approaches -5 from the left of g of x.
Oh, -5.
So,
I got 3 plus 3.
you're ahead of me. What are we getting?
Yeah, like I can't think right now.
Oh wait, -5.
-5.
-5.
Yeah,
I'm like,
coming from the left.
oh my gosh.
Yeah, I got 3. Is it? I keep forgetting. Does it matter if there's 2 points on that spot on the first one? Or no, because it's coming from the
Because
left.
it's coming. Yeah.
Okay, so it's
Yeah,
coming
it's
from the
like-
left on F. It's coming from the left, so it's going to come in at 3.
3
And then,
minus 5. 4. Yeah, 3 minus 4.
Yep.
I think that's what Eli said.
I hadn't said anything. I think credit goes to Eli on that one.
I just couldn't think. I was sitting there staring at it. I was like, what am I doing?
D, we have a division going on here. Okay?
Yeah,
You've seen how we've been breaking up addition, subtraction. Division can break up the same way. That 3 out front can go out in front of the limit. So we're going to have a limit of f divided by a limit of 3. But on top, it's going to be 3 times that. So I'm going to write this as on top, 3 times the limit as x approaches -7 of f of x divided by the limit as x approaches -7 of g of x. Okay? So, 3 times something divided by something.
3 times 5.
I got it.
Check that 1.
Yeah, I didn't. I was gonna say over 3.
Oh, over 3.
We're using the
I
asymptote
confused
as an
the
x and
asymptote
that.
instead of
Okay,
X.
that was my guess. That's why I said check it.
Mm-hmm. Maybe.
I could see where you were getting. I was like, okay, I bet he's seen the asymptote. Okay. Realize 3 times 5 divided by 3. Yeah, it's 15 divided by 3. Or cancel the 3's and it's just a 5. Okay. Catching on, yes?
Yep.
So E, I can take the 4 out front and then have 2 limits. So 4 times the limit as x approaches 3 of f of x times the limit as x approaches 3 of g of x. Okay?
Be 6. 4 times 6 times 4 times.
Only 1 4. The only 4 is out front. You don't distribute it
Oh,
because this is not addition. So it's just 4 times the limit of f times the limit of g. If this had been like a plus sign in the middle of them, we could talk about distributing or just, using the parentheses. But
Mm-hmm. Is that going to be 1?
this is where I'm waiting for everyone to get on the same part here.
Yeah.
Notice I didn't put an answer.
It's either 1 or not. Or not.
4 times 3, right? Or 6.
Yeah, that's.
Okay, we're looking for it.
Limit as x approaches 3.
X approaches 3.
From both sides. I don't think it's.
Yeah,
From
it's gotta
both
be
sides.
D and E, right?
That's a D and E.
That makes the whole thing D and E, right?
Exactly. 4 times 6 times does not exist is
I just hadn't gotten there yet.
I know, that's why I was waiting for everyone to get caught up. So, okay.
I went to use my whiteout and the thing was off center.
Okay, F. A power. Basically, you can find the limit and then square your answer. It's not squaring the answer, or it's not squaring the function and then find the limit. It is, we're going to do the limit as x approaches negative 3 of f of x. We're going to get that whole limit, and then we're going to square it.
-6 squared.
Okay.
And do we have to rewrite into the other rule?
Like, are you talking about this part here that I'm doing?
Yeah. Oh, I didn't do that.
Not necessarily.
Okay.
I mean, it's good to know, but I don't know that you necessarily have to. Okay. What's going to happen on G?
Square at last.
Square root at last, right? So we can do 8, because that 8 can come out front, times the limit as x approaches 4.
When you look at 8 under there, like I know
Well, it's going to be. But we're going to do the 8 times the limit, and then the square root of the whole thing, or what's that as a power?
What?
What's a square root as a power?
Power 2.
Not power of 2.
1/2.
1/2. So you could write it as a square root, or a little bit of a reminder there, it's a power of 1/2. And that's why the rule works, because it's just another power. So 8 times something and then the square root of it. 8 times what?
G of x, x to the 4. 5.
Mm-hmm.
And 8 times 5 is
40.
square root of 40.
So it can be like 2 square root of 10.
Yeah.
Mhm.
Yeah.
I mean, I haven't really talked to you guys much about it, but on something like this, these would definitely be no calculator problems. Okay? At least half of your AP exam is non-calculator. So we have to learn to work without the calculator. Not that you guys have been grabbing the calculator for this stuff, but just saying. Okay? And in terms of square root of 40 or 2 square root of 10, as long as they're equivalent, they're both okay. On a multiple choice problem, you just have to be able to recognize they're equivalent. Okay? Okay. How are we doing? How much more do we have to do? We have a lot, don't we? Well, yes and no. I'm trying to think.
Skip to the fog.
No,
Yeah.
we can't skip the fog. That's right.
2.
I will say, just, H, if you go back and look at it,
You get plus. Yeah.
you get another D and E, so the whole problem is going to be D and E. Okay?
Oh, it can't just be like -6?
No.
You're not multiplied by it.
Yeah, but when you're trying to add on something that doesn't exist, it just makes the whole problem not exist.
I think we can skip the.
J ends up being 0 divided by 5, and what do we know about 0 divided by anything?
0.
It's 0. Okay, let's talk about fog here. So this is going to be rewritten as f outside of the limit as x approaches -2 of g of x. Like any typical math problem, you start inside the parentheses, right?
Mm-hmm.
So we start inside the parentheses
-2.
as x approaches -2 on g of x, it is
-3
-3. So now your problem becomes f
of -3, which would just be -6, right?
Yes.
Okay, because now we're not doing a limit, we're looking for a point. F of -3 is indeed -6. Okay?
That makes more sense than regular fog.
Well, okay, you guys have also suffered through 2 years of doing fog and golf with me, and maybe finally it's stuck.
Sure.
I don't know. Guess what? Fog and golf are coming back in calc. They're not gone. Okay? You gotta know how to do fog and golf.
I roll when it
13
comes to-
examples in 20 minutes.
We can do it. Or not.
Or just
Okay. Did I just skip a page? Oh no, I had 2 of the same page up here. That's why I was like, whoa. Okay. Now, another way. Okay, we were just presented graphs. Here's another way you might be given it. Given the information, the limit of f is 3, the limit of g is -2, the limit of h is 4. What makes this nice is they're all limits as x approaches c. So they're all going to go together. Okay, they're all going to work together. Now, really? We're just doing the same thing we did on the other page, if you ask me. My properties say this can rewrite with the square root outside, yes. 3 times the limit of h minus 2 times the limit of g. So if I do all the fancy rewrite, it's 3 times the limit as x approaches c of h of x minus 2 times the limit as x approaches c of g of x. And then your last step of all of it is going to be to take the square root. Or I'm writing it as raised to the 1/2 power, but it's square. We're going to do square root in the end. Now, it might be easier because you don't have to look at a graph. So it could be quicker for us. So 3 times 4 minus 2 times -2 and square root of all that jazz.
12 minus 4 is 8.
Whoa, 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 back up.
12 minus -4.
16.
Square root of 16, which is 4. Okay. B. I'm going to save the time. I'm not writing it all out. I am going to still on some of them, but not on this one. What do you see here? The limit of f
Times
5 times
2.
the limit of g.
So it's really just 3 times 5 times -2, right?
Yeah.
Okay.
Okay. Now don't get too quick and, like, oh, I'm just going to skip writing it all out. There is times you need to, be able to write it out and whatnot.
Yeah, like D.
Okay.
Oh,
In all honesty,
That
no,
looks-
D is
that's
actually not
pretty-
too bad.
Yeah.
Okay. If I do C, I'll write this one out. The limit as x approaches C of 7 minus the limit as x approaches C of g of x. And then we're going to do quantity squared. Okay. What about the limit as x approaches C of 7?
it would be just 7, right?
Yeah.
This is like, this is the K.
Properties,
Yeah.
This is the K one, the constant one. So that's just 7 minus,
-2.
and then quantity squared.
So 81.
Okay. In all honesty, and this is where I'm trying not to get too sloppy because I should be writing these out. I shouldn't be skipping a ton of steps, but I'm not gonna write D out in terms of all the fancy. Because 2 times the limit of f plus 3 times the limit of h divided by the limit of h minus the limit of g. And I'm only doing this because I also feel like you guys are okay with it.
6
6 plus
12. 3.
Okay? Now, I am going to write the next one out a little bit. I don't know if you'd have to, but I'm going to. The limit as x approaches c of h of x. And then notice it's times f of x plus 6. So I'm going to put like a bracket, just, or like a big parenthesis. Guess I could just do a big parenthesis there. And then it's going to be times the limit as x approaches c of f of x.
And then times the 6 too, right?
And then, well, plus
Well, that's what I meant.
the limit
The limit, yeah. That's
as x approaches c of 6.
it did come out right. That's what I meant.
Okay?
So, 4 parentheses 3 plus 6. Yep. 4 times 9. 36.
Okay. F, do I write it out or do I skip writing it out?
use
You think I can skip it? Okay.
3 squared over 4 minus -2. So,
Now, this gives me a good discussion point.
3 over 2.
You leave 9 over 6 in calculus, you get it right. Okay?
Oh, that's such a W.
So, AP exam.
Yeah.
Okay? A bunch of your AP exam is multiple choice. But you have 6 free response problems. Some of them are on calculator, some of them are with calculator. But here's the deal. You leave any equivalent numerical answer on the free response and it's equivalent. So the simplified answer is 3/2, correct? You leave 9/6. You're good. Officially, this is a numerical answer. This would be equivalent and count as good officially. Now, will you see something like this easy on free response? No. I mean, it's not this basic on free response necessarily, but you leave something as long as it is simplified. Now, I ask that you don't leave something like that from me. I do ask that you try to reduce. However, on the flip side, I've heard calc people say, well, don't reduce, because if you make a mistake reducing, you just lost the point. Whereas if you stopped at 9/6, you got the point.
I think
So.
I can judge myself.
So,
Until it's 512 over 16, then I'm going to leave.
Yeah.
well, definitely.
That's probably why.
I'd probably leave it
Yeah.
there.
But
9
I mean,
over
but the
6, I
thing
think
is,
will be
something
okay.
as basic as 9/6, can we mess it up?
Yeah.
We can.
I definitely have before.
Exactly. We all do. Okay. This one. They just gave us some new information. The limit of f is 8. The limit of g is -4. And then they give us some craziness.
Dude.
I kind of want to.
I'm not writing limit that many times.
Well, officially, I was going to write limit that many times.
2, 8,
It's 2 times the limit of f. Oh, you guys are going to get done way before me.
8.
Times the limit of g minus, whoops, I'm going to say the cube root of the limit of f plus 2 times the limit of g, and that's squared. It's craziness, but it's not that bad.
6 times 8 times -4.
I have an answer.
I'm still working, so.
Hey, that's all I got.
Yep.
And I wrote it in pen. That's a good thing.
Oh, Logan. Okay. Limits. You're just learning the very basics about limits here. So, okay, one more page.
Good, it's just been the same thing the whole time.
Huh?
I feel like it's just been the same thing this whole time.
It has to an extent. Okay. Find the limits of the following composition functions. We're going to talk a little bit about fog here. Given f of x is defined as follows and g of x is defined as follows. Find the limit as x approaches 2 of f of g of x. Now, officially for this work to work, we'll talk a lot about continuous this year, and our f of x and g of x continuous functions. Okay, continuous function meaning, you know, you can draw it all in one path. And I can say they are because they are polynomials there. Okay? Now, with that in mind, I'm going to start by rewriting this. It's going to be f times the limit as x approaches 2 of g of x. Yes? Okay. We've got to start on the inside. How do we do the limit as x approaches 2 of g of x? Basically, you're going to take 2 and you're going to plug it into the equation. So, what is g of 2? And g of 2 is the negative 4.
And then you plug that in.
So yeah, then you just.
And then you're doing f of negative 4. Yep.
Negative 4 squared. 4 times negative 4.
And this is where, and you guys haven't been, so, you know, don't grab the calculator. Work to do this type of math without a calculator.
I think everything's negative, isn't it?
Yes, I agree. Oh, shoot. I just did my math wrong, too, so.
So I initially had a negative 129, so.
Okay, I hope that's not our connection there because I did the same. I said negative 129 because I said 16 and 16 is 32, and then my brain, it just became a 64, so. Okay. Are you okay with that, Eli?
Yes.
I would say it just really comes down to careless mistakes, really, is what we're
I'm
making
trying
probably.
to do 4 numbers at once.
Fair enough, yeah, that's, well, and I, you know, this is, you can see what I did. I did 32, and then 64 plus 32, and then the 1. But that's how my brain works. Everyone sees mental stuff differently, so. Okay, so you think you can handle this one then? This is the limit of g of f of x, so we're going to do what? G of the limit as x approaches 2 of f of x. So again, start on the inside. The limit as x approaches 2 of f of x. As long as these are continuous graphs, you can plug it in.
Where does it say they're continuous?
It doesn't. One of the big things we'll talk about this year is that these are polynomials. An x cubed graph, you guys know about x cubed. They're the curvy graphs, right?
Mm-hmm.
They're continuous. Negative 2x, it's a line. They're continuous if it's just a bunch of polynomials added and subtracted together. Or monomials added and subtracted together. So.
Negative 22.
Yep.
Okay. So, yep. G of 11, and then G of 11 is negative 2 times 11, and as you guys said, negative 22.
5 minutos más.
Okay. Use the graphs of f and g. So we're back into using graphs to find the limits. And we're more practicing the Fogg and Goff stuff. Okay, your compositions. So f of the limit as x approaches 3 of g of x. So pay attention which graph you're on.
Oh, yeah. It would be 1. So f times 1.
F of 1. So
F.
the limit as
F of
x approaches 3 of g. So we're here on g.
And then be
As x approaches 3, that's at 1.
Mm-hmm.
Now we're doing f of 1. This is not a limit.
Yeah.
Did you guys say negative 2?
Actually, yes.
Or did you agree to it? How's that?
You know, the graphs are what mess with my eyes.
Okay. Limit as x approaches negative 1 of g of f of x. Oh, shoot. G of the limit as x approaches negative 1 of f of x. So g of something.
-6. G of -6
Would be -4.
And
Wait, no.
Okay, so you kind of have to figure it out here, yes?
So negative.
There's an arrow. You can see that it keeps going here, right?
you can figure out the slope way. Yeah.
Yeah, but essentially you're thinking slope.
Negative. Yeah,
Okay, so yeah, you're essentially using the slope, the rate, and at -5, you're here at -5, right?
mm-hmm.
So then at -6, you're going to be down here at -7. Fair enough? Okay. C, there's a catch here. Why is there a catch on C?
Hang on, let's figure it out.
F of, okay,
Let's
so
figure it out.
we're doing F. I'm trying to remember what the catch is, and I didn't look. Yeah, probably. So as x approaches 1,
Oh yeah, it's a D&E.
okay, and we're out of time to talk about it, but you have a D&E there, and so that gets it where it gets a little peculiar, huh?
F of D&E can technically be.
Well, because, what is it? Okay. Because they both come from above, which is the unusual part there. It's not guaranteed to be a D&E in the final answer. Okay. What we're looking at here is where it's coming in to meet them. And does this one appear in homework? Because I don't know that I don't really have time to go into the specifics of it. I don't think it appears.
One, yes, I think. Is that 10?
Yeah, 10's a more basic, like what
Yeah.
we've already done. We don't have the D&E issue in the Fogg and Goff, so I'm not going to worry about it right now. But you do run into an issue of, oh, this guy does a D&E, so what exactly does that mean? Okay. Technically on this one, it could come up with an answer, but it's a special case. Okay. If you happen to do D, I don't know if you did or not, you could get an answer as well. Okay. I kind of like that they're not doing announcements because that takes away my time. It does. But
I'd also like to know.
I was gonna say, it's also thrown me off, like, oh, I gotta really watch my time here, so. Okay, so work through the homework for tomorrow. I think you'll be okay.